AI.
Artificial intelligence.
It's called chat large language model.
Artificial intelligence is on the rise.
These days, right, I think everybody already experienced interactions with ChatGPT and Claude and Gemini. It's a very intuitive interaction. So however, these models only produce language and vision or images, and we are wondering, can we actually leverage them to produce actions? Welcome to the Intuitive Robots Lab. We have a team of roughly 8 people, myself, and then like a lot of master students, bachelor students. What we're doing here is we're focusing on intuitive human-robot interaction, and in particular, we want to develop new AI and machine learning methods that help robots to behave more intuitively around non-expert people, like for instance, elderly people and so on. So Flower is our first approach and arguably even one of the, if not the first European vision language action model. So models that take these VLMs like ChatGPT, Claude, Gemini, and retrain them and adapt them to produce behaviors. We need just a fraction of a compute time compared to our large competitors, while still having competitive performance and even outperforming them on various benchmarks. Like a GPU that you just buy in like some store, right, is sufficient to execute this intelligent behavior on a robot at home, for instance.
Okay, so I have started the data collection script now.
Okay, almost there. Need a bit pressure.
There are like 2 common ways like nowadays to teach a robot to learn some new skills. One is called imitation learning and the other is called reinforcement learning. So in our lab, for most like real robot tasks, we do like imitation learning, which means we ask some like human operators to collect a bunch of like demonstrations showing the robot how to do specific tasks. Then we ask the robot try to mimic those like human demonstrations. Then it will be able to do those tasks without like human supervision autonomously.
This is actually our newest work, right? So like work in the domain of vision language action models. And what it does is actually that it takes behavior and actions and things that we actually observe as something like interacting with the environment and represents this as tokens for VLM. So a token usually is just like a set of numbers that corresponds to a particular word, a partial word, or like an image. So now we can actually take this VLM and can retrain them on these new tokens so that instead of producing language tokens, it produces tokens that correspond to an actual behavior, to performing something in the environment.
When we look into Flower, even with Flower, we are always assuming that we have multiple modalities and the data is always incoming. And with my research, I'm also looking at Flower, but from the different angle, reliability angle, that if one camera is occluded, you have placed a hand or some dust particle came or something in the camera broke off. In that case, can we still retain the performance of Flower?
Within the next 5 to 10 years, I actually want to see our methods deployed in small and medium-sized enterprises and large enterprises. I want to really show that what we're doing helps people in their day-to-day life. Of course, like this is like a very common question these days, like can we in Europe or in Germany even compete with the resources that are available to our colleagues in the US or in China? And of course, like we have to be realistic, we don't have these type of investments. So how can we make our methods more efficient, right? So to require less data or to require less compute in the first place, right? While still showing that we can outcompete or even like outperform our like this larger or these approaches that just use more compute to solve the problem.